Learners. Today we'll be seeing an important concept that is byte addressability. Before that, I would like to request you all to please do subscribe, like, comment, share this video to your friends so that it reaches maximum student. So let's get straight into the concept. Today we'll be seeing about byte addressability. So what is byte addressability? Okay, the in byte addressability, what happened is that it tells how memory will store data. It will store in the format of byte. I will be explaining you all how memory stores the data. Here, they have given that byte addressable memory successive addresses means successive addresses refers to successive byte location. I would like to request you all to please look at this image that I've given here. Don't be bothered about what is little Indian, big Indian, and little Indian. I will be explaining you all shortly. So please do concentrate on this diagram so that it will be easy for you all to understand. Here, they are given byte addresses. So what they're telling is that this successive addresses refers to successive byte location. This 0 is one address, okay, and this 1 is another address. So these are successively placed, right? They're placed one after the other. So from 0 1 2, this zero block here I'm marking, this 0 block will give you 8 bit. We can place here 8 bit of data, okay. So what is 8 bit? As I've told you all earlier, 8 bit is nothing but 1 byte, right? 8 bit is equals to 1 byte. Then what will the next block, that is this block named 1, will contain? It will also contain 8 bits, means this is 1 byte, right? And this also will contain 1 byte, and this block number 3 will also contain 1 byte. So now you all will be able to understand what this first line tells. It tells that successive addresses refer to successive byte, which means the 0 is an address, 1 is an address, 2 is an address. So these successive addresses refers to successive byte. From this, if I start at 0 and go to start from address 0 and go to address 1, what this address is, it is the successive byte of what was previous, right? So yeah, the byte location have addresses. As I've already explained you all, byte location have addresses 0 1 2 3, so on. If the Before getting into the third line, 32-bit, as I've told you all, 32-bit, what is called as 32-bit, a word is called as 32-bit, right? So let's see how how the word will be placed in a memory. So this is how the word will be placed in memory. This is how the bytes will be placed in memory. The word, so before that, how many bytes will give you a word? So one byte, okay, one byte is, I mean, 8 bit, it gives you 1 byte, right? 8 bit gives you 1 byte. Then 4 bytes will give you 32 bits, right? If I'm not wrong, 4 bits will give you, I mean, 4 bytes will give you, that is 4 into 8, right? 4 into 8, 4 into 8 will give you 32 bits, if I'm not wrong, will give you 32 bits. So here we have 4 byte. Here we had 8 bits, right? 8 bits in each block, from 0 in 0 8 bits, in 1 8 bits, 2 8 bits, like that we were placing 8 bits. And 8 into 4, what is 8 into 4? 8 into 4 is 32 bits. So here I am placing 32 bits, and in the next row also I will be placing 32 bits, right? This is what the third line refers here. Successive words are located at address 048. If I am placing here 32 bits, here also I will be placing the 32 bit, which means what I'm trying to tell is that this is word address. It starts from like byte address 0 1 2 3. Next it has to go to 4 5 6 7 because it is successively placed. So here if I place here at this address, which is at address of 0, if I place 32, at the address of 4 I have to place another 32 bit. So here I will have one word, here I will have another word. This is what here they're trying to tell. So I hope that this basic concept is clear for you all. If this basic concept is clear for you all, now we will be able to understand what is big Indian and little Indian. Okay, fine. So what is big Indian and little Indian? You all know that what is what is MSP and what is LSP. I don't want to explain you all again. Like, I hope you all know what is LSP and MSP. Okay, MSB and LSB. So what is MSB and LSB? You all know that, suppose if I'm given some number, like assume 5, 7 and 2, some number, random number or data like this 5 will be the most significant bit and this 2 will be the less significant bit, right? Similar concept also applies to more significant bytes and less significant byte. So if this 5 is a byte, the 5 represents a byte, this 5 will be called as more significant byte and this 2 will be called as less significant byte, right? In big Indian or little Indian, the lower byte address remains the same. This here, this zeroth address will be the lower byte address, and similarly here, this 3 will be the lower byte address. Suppose if I given the same, I'm sorry, if I'm given the same data 572, this 5 will be placed here, as this tells lower byte address are used for more significant byte, means the lower byte address, which is named as 0, will be used for this more significant byte, and this lower byte address which is named as 3, here what will be placed is that less significant byte will be placed. Let me make this concept even more simpler. If you all don't remember this concept, just remember this example where you will be using 1 2 3 till 8, which is a 32-bit integer, and you will be dividing it as uh, two numbers each, which is like 12 as 1 byte, 34 as 1 byte, 56 as 1 byte, and 78 as 1 byte, which in total as 4 byte. So if you assume that addresses starts from 1000 and ends with starts from 1000, and place this 12, 34, 56 in the same order as they are being divided into bytes, this 1000, in 1000 you will be placing 12, and in 34 you will be placing 1100, and in 56 you will be, I mean in 1200 you will be placing 56 in the same order. If you place, it is nothing but big Indian. And if you reverse this number, like 78 first if you place in the 1000, and 56 you place first next in the 1100, this will become your little Indian. If you don't remember this concept, just remember this example, which is very simple to remember. If you all remember this concept, it is more than this example, it is more than enough to fetch good marks. So now let's see the concept in detail. Yeah, see here, in big Indian representation, most significant byte of the word is stored at the smallest memory address. As I told you earlier, this this is most significant byte. It will be placed in the smallest address. This is big Indian, and the less significant byte, which is 2, will be placed in the address 3. The concept is very simple. Here, as far as I know, they will be giving you all some data and tell you all to represent it in the form of big Indian and little Indian. As far as I know, the data they will be giving you is Belagavi, VTU Belagavi, to arrange this in the form of big Indian and little Indian, whereas like you all will, and they will be giving you all the corresponding ASCII character for this, and will I'm sorry, and you all will be placing this in the form of big Indian and little Indian. This example you all will be getting in, obviously, in Google. Please search through that and the concept will become easier